Hello everyone. My name is Björn Skoogh. I've been invited here to talk about a really interesting project we have in Sweden with a large real estate owner called Vasakronan. I come from SWECO. SWECO is mostly known for its civil engineering projects, large and small. But today I will talk a bit about some IT solutions that we help our customers with. I hope this works. Yeah. Vasakronan is a reasonably big real estate owner. And they're the leading property company in Sweden and focuses mainly on offices and retail. There are some apartments too, but that's just a really, really small piece of their business. 179 properties, each of them divided into one or more buildings, of course. 4 regions. The regions they focus on are the main economic regions of growth in Sweden, like Stockholm, Gothenburg, Uppsala, and the Öresund region. And they are quite valuable, 116 billion Swedish crowns on 350 employees. So if you do key figures based on employees, they get really nice values. We started this project in 2005 with Vasakronan. And at that time, they had an unstructured handling of their drawings and models. You can find them in USB sticks. You could find physical archives with paper drawings and mailboxes and servers. So we started a project where we created a solution to structure all this, to get it all in one place, with a file-based, with the properties on the files. They made it searchable, made it in a way so you could have a flow of information between the projects and the buildings. And we introduced an online storage for this to create an industrial way of handling the information. The online repository was divided into 2 parts, where one part managed the projects and one the building archives. And it had, you know, the usual stuff for, and it still has, by the way, they still use it, for versioning, for review, approval, rejections. You could package documents for various stages in the projects. And they also updated their CAD guidelines and started to industrialize the flow of information in their project too. But we're still talking about the information about the files, where they are stored, where what is the information. How do you say in English? The stamp on the drawings and so on. We also introduced redlining and markup functionality to capture all the changes that takes place between projects and maintenance. And perhaps the most important piece was that Vasakronan decided to take ownership of the models, not only the raster files and the CAL files or PLTs, as it was back in those days. And they started to upload the models into this online file repository. And they run approximately 400 or 500, sometimes it's more, sometimes it's less, but any given time they have, a lot of projects ongoing in their organization. So there's a continuous flow from the property model archive to the projects and back again. And they started to also introduce CAD coordinators in the projects to help make sure that the models delivered and the files delivered were according to their specification and according to that, to the CAD guidelines. And we also introduced automated controls of properties to make sure that the consultants couldn't upload stuff into their database that wasn't controlled. And now, a few years later, there's a lot of information in that database. In the projects, there's approximately 1.6 million models of various kinds, and about 450,000 models in the property model archive. That includes version. Without versions, there's about 1 million files in the projects. And that of course, includes other types of files, like time plans and financial documents and so on. But it's still a lot of documents, and they started to take ownership of this and put it in one place. And in 2005, most of these drawings was of course raster files, PDF, CAL, PLT, and so on. About 80–90% of all the buildings were represented like that, and the rest were DWGs. But of course, back in those days, those DWG files were mostly, lines, and perhaps not so many objects. And if we fast forward about 10 years, we see that 80–90% are DWG models, and of course, object-oriented to a much higher degree. But we also see an increase in BIM models, mostly Revit files actually. And from 2015 onwards, there's a steady increase. And if you take into account that they are continuously doing these 400 or 500 projects, the number of BIM models are going up rapidly. And they have also added, of course, BIM guidelines in addition to the CAD guidelines. We're using BIP codes and co-class, etc. And they use BIM coordinators in the projects, or BIM managers, as you spoke of earlier. And that's actually a very important role. Because they stand on the same side of the people who is ordering the building or whatever, and try to represent their needs and to keep the consultants in check. So I think it's a very important role. Those are still files, but the interesting thing about this project is what we're trying to achieve. And we try to move from those files to information instead. And what this means is that we make the models accessible, we make them available to various systems and applications and users that can consume them in various ways. So we have developed a workflow where you have the BIM model in its native format, all those big software solutions can export to IFC, so we use IFC, so we don't have to write extraction engines for Revit or Tekla or MicroStation or whatever. We extract from IFC. And what we do is that we extract the geometries, the objects and properties, and put it in a database. And when it's in a database, we can query it through an API, a way of asking questions to that database. So we can make the information available from many perspectives in an organization. It could be from calculations, simulations, maintenance, or whatever. The main thing is that we abstracted away from the actual file, the model, and put it in a database. In this case, there's a viewer over here, and of course we have provided a viewer that talks to the API, but it could be really anything, another system or whatever. And if you keep the blue square in mind, you soon realize where they want to go with this. And I think this is really important because Vasakronan is such a large actor, and what they do, at least in Sweden, matters. So this philosophy is very, very interesting. They're actually trying to give the model equal value to all the other ways of looking at real estate and buildings, where in most normal cases, the facility management system have their own truth, their own way of representing a property. The building automation systems has their own truth. The ERP systems or the financial system have their truth, and so on and so on. But the idea here is to create a common truth, a common way to represent a building and an organization, and let all these other systems query that model. So you can get a shared view of areas, volumes, objects, assets that are shared or between all systems in the organization. And of course you can write applications based on this that uses IoT sensor data and BIM model data together, for example, or building automation data and the BIM model. And this is kind of an interesting approach, but this worked in Vasakronan, is working because this is an ongoing project, because they had the IT infrastructure to support this already. So they had already built for these systems, the facility management, building automation, and so on. They had built layers of abstraction so they could lift data from those systems and make them accessible through the API. So what we are doing is that we take the BIM model data and lift it to the same solution. So it will be represented equally with the other systems in the data warehouse. And then they already have in place, they work a lot with something called API management for the IT guys out there. So they can create task-based applications for various roles in the organization that collects data from all these systems and use them in junction. So this is what we're trying to achieve today. But when you abstract the model, all kinds of possibilities end up. So we have actually done a lot of small proof of concept, small tryouts. We use a methodology called, I'm sure you're familiar with, minimum viable product. So we do a lot of small steps. And we try to use this data from other perspectives. And when we have abstracted it from the file to the database, we can consume it in both the ways I was talking about earlier, but also in VR, in AR, on a screen, on a tablet, on a phone. So we try to make the information available for maintenance personnel or whatever, sales personnel from different perspectives. So, and we have done proof of concepts on most of these things. So I have to stress that this isn't actually in place. Parts of it are, but not the entire thing. But it works. And we can query from for example, Daydream or Oculus Rift, the API, and get a raw model that we can view for customers, consultants, construction companies, to get a view of the buildings before it's built, for example. They have asked us to create an enhanced view where we add layers of textures, lighting, shadows, and so on, to provide a simple solution for the sales personnel to show a potential customer a model. You can put textures through this pipeline too, but if they don't have any, we have a texture repository where we can, as long as we know what material, as long as you have stated that in the BIM model, we can add from a small library of textures. They also want to put the building in its context. They want to be able to, from a tablet or a VR or whatever, show the surroundings of a building. And all these regions I was talking about earlier, the Öresund, Göteborg, Stockholm, Uppsala, have digital maps of their cities. So, and those are available through open APIs. And so we can put the model from the database on top of those city maps, 3D with draped photographs over it. I'm sure you have seen such maps. And we can put the model inside it, and you can put yourself inside the model and look out and see the city outside. And of course, they want to try out auto-population of furniture through algorithms that, for example, if you have an office, you want to see how many workplaces you can put in there. There are standardized setups with a screen, a desk, a chair, and an auto-bounding box. And you can auto-populate this by certain rules and see how it works. And they also want to be able to consume that through all these perspectives. We have also been doing some testing with products like the HoloLens, where we have, together with the University of Chalmers, created a spatial mapping solution, where we take the meshes and from the HoloLens and convert it to planes. And when we have the planes, we can compare those planes and geometries to the spaces in the BIM model. And when we have those, we can start drawing things and mix reality with digital objects. So we can start see what's behind the wall. And we can get information about these objects, as long as the BIM model is correct, of course. But we have BIM managers, right? And we also want to take care of all the other files. Those two up there are gray. We haven't started anything with those yet. But the plan is to bring in the 2D files too into the same database. We'll see how that goes. And they also want to, if you see this one at the end here, they also want to consume this data from a multi-user perspective. So you can have one user with a VR set, another one on place in the building with an AR kit. Perhaps one person is in a train. They all share the same Skype session, and they all can consume the same data and be aware of each other's presence and communicate about the same objects and information. And we're also visualizing IoT data in this. And to make things even more interesting, there's a small box to the left, upload client, it says. This is also an ongoing project. We have created an upload client that loads up files into the online repository. This is mainly for maintenance documentation, but it can be used for about anything. And the interesting thing about this client is that it uses something called artificial neural networks. And that's a way to train computers to see correlations and act upon them. So what this does is that it takes the information about the local path of the file name, the user's company, properties of the file, and the indexed content of the file, and suggest where it should be stored and what properties it should have, so it could be reachable from this solution. So this is what we're trying to achieve. And what makes it possible? Yeah, structure, of course. Perseverance. This hasn't been a straight road. There has been many troubles and hiccups, but we try to keep our chins up and move ahead, and it works. They have an initiative called, they call it VK Core. VK is Vasakronan, of course. And this core initiative is an enabler of all this, where they have created, how do you say, a way for the building automation systems to understand the properties from the BIM models. So more or less a translation between different standards for their own use. And I don't think there's a coincidence that the person leading that initiative is a PhD in machine learning. So I think we will get very interesting things there soon. And of course, the abstraction of BIM is an enabler of this. Without putting the models in a database, these things would have been much more difficult for us. And the curiosity and vision of the customer, of course, of Vasakronan. I remember one meeting where, when we started this, and the IT director of Vasakronan, Søren Sundell, he said that now we need to stop talking and start doing. We are tired of being BIM tourists. And I think that was the start of this project. That's about it. It was all I was going to say about this. Thank you for listening.
Thank you very much. Ačiū labai. Jeigu auditorija neprieštarauja, jeigu nieko prieš, pabandysime pasivyti tvarkaraštį, šiek tiek vėluojame. Tai jeigu turite klausimų pranešėjų, tai manau, juos galėsite užduoti asmeniškai pertraukėlių metu arba rasime laiko konferencijos pabaigoje dar paklausti klausimų, kurie susikaupė visiems konferencijos pranešėjams. Taigi, thank you very much once again.